Hey guys, I'm Avi, and I want to share with you our achievement and our breakthrough, technology breakthrough we got in in my last role as head of data science in the world of edtech and advertisement. So let's start. So little bit about myself. I'm currently a director of data science and AI and at First Digital Bank. It's a new bank in Israel that maybe you are going to hear about soon. I have an experience of like 10 years at AI, big data, machine learning, deep learning in different use cases and usages, and also with recommendation systems. So what is the problem that we try to deal with? The problem is that we got billions of events in our data, billions of clicks, for example, and impressions on different kinds of ad units for advertisement purposes. And we used different kinds of more classic machine learning tools to build a classifier to predict if someone is going to click or not click. It's called CTR on a specific ad, on specific request from a publisher. And we have a lot of painful trade-offs. We had a skewed feature. We have a lot of skewed. The main skewed feature was the ad unit, because every ad unit perform in different way, behave in different way. We have a different label data for every ad unit. And when we try to build one model, for example, one XGBoost classifier model for this goal, we got a very low AUC and accuracy for this model in many types of ad units and requests. And we thought how to handle this and which research analysis we need to do. So the research we done is the first assumption that we had and we want to check and research on is to split the data to smaller data sets per ad unit, because we saw that every ad unit has a different behavior between each other. And when we built in our lab a model for each ad unit and for each data set for this ad unit, we got much higher results in accuracy and AUC. So we understood we want to build a model for every ad unit, and it caused new problems and issues. The first problem that we got is to train 20 models for 20 ad units in much the fastest we can, and when we run it one by other, we finished to train all the models in 8 hours, and then we ran the validation and so on, and decided if we want to deploy it to production or not. So it was already obsolete because there were features with new values that we didn't try that came to our data in the last 8 hours, and the model, for example, campaign ID, new campaigns that started in the last 8 hours, and the model was obsolete for those new values in the features. The new issue here was that when we tried to run it on the master of the cluster, we prepared the data for the model because it was big data. We used Spark to prepare the data set for the model, and on a cluster, on huge clusters. And when we collect the data to the master to save it, when we collect the data to master, we try to collect the data to master and then run there the model. but it didn't use the cluster power. It only used the master. Also, if you have like autoscale and the other instances were already dead, we want to, for example, use the cluster to run all those models in distributed and scalable way. So other ideas that came through, it was to use, for example, Airflow to run the models on Docker, and we found ourselves defining pipelines for each type of model, and it was very problematic because we have a different amount of data for every model. For example, we had one ad unit with 100 million rows, and we prepared from it a sample of 10 million, and other was like 1 million rows, and we used all those rows. So the difference was from 1 million to 10 million, and if you want to optimize it, you can choose different type of instance, Docker instance, to run those models. So and all those type of things can change in 1 month. It can change from 1 million rows in a specific ad unit to 5 million rows. So we don't want to maintain this all those pipelines for all those 20 models, and we thought maybe how to continue using our own the technologies we already used, and how we can leverage them to solve these problems. So a little bit about the machine learning model lifecycle and how we want to, in the end, want to run it in distributed and scalable way. So we have the first step. It's like the data preparation, data cleaning that we want to do for our row-level data. We want to prepare from it different kinds of aggregations and maybe features for different kinds of models. And after it, we have the data transformation for a specific model to prepare the specific data set for training and validation. In this pipeline, after we prepare the data for specific model, the train data and validation data, we are starting to train the model, and after it, in circles, we want to do hyperparameters tuning, and again, after we are getting the best model that we can, after doing validation and see that we have good results by our matrices. After it, we, of course, doing the prediction that we want to do is more as an offline example. We are doing the prediction on the model, and then we are starting to do a model evaluation, because we want to see if kind of a post-validation step, that we want to see that the true data that came versus the predicted data, and check our matrices again on those in this post-validation. So before I'm jumping to our solution to this main problem, I want to share with you a little bit about the background of our text solution, about all the technologies that involved in this solution. We have here we still want to use Spark. We are preparing there the data, and since Spark 2.3, we have integration with Apache Arrow to improve the serialization between the Spark data frame and the Pandas data frame, for example. And they also add different kind of tools like Pandas UDF that we want to talk about in a second. So Apache Arrow helped us a lot to improve and optimize the memory usage and the CPU or GPU usage. The Apache Arrow is doing all the serialization in much better way in terms of memory, and also in terms of CPU computing, because it uses a much more suitable data model to save the data in memory, and and do the compute on the CPU. So all of this is running on the background, and also this integration with Apache Arrow between Spark and Apache Arrow come with new features for Spark. For example, Pandas Group UDF. It can help us, for example, to run a group by on the data on specific columns and pass a Python function that we want to do on this group of data. And this calculation, the Python function, will run all over the cluster, all across all the instances of the clusters and workers of Spark, and of course run in distributed way across the cluster. So it's new way to combine between, to transform between Spark data frame to Pandas data frame and run the Python code on the Pandas data frame across all the cluster of Spark. Quick example, you can run here in the group by df.group by. You can pass here all the columns that you want to do group by. I can give her a teaser that we are going to run it on a unit column, and then pass to apply the function that you want to run. It can be any Python code, or for example, XGBoost code to train and validate and do the post validation on the model. So here we come, our solution. The most important thing that we want to achieve here is first of all the improvement in accuracy by running 20 models in scalable distributed way, but also save to find a most simple way to do this in more generic way. If we, for example, want to run like 500 models or 20 models for very different use cases. So in this way, we can support like 500 models in parallel without any much code changes. Just change the group by column that we want to run the models on. So here we can do a more deep dive on the data preparation in our solution. So we have here compared to our last solution, it's much the same. We are using Spark to prepare the sample for the model. The main difference here that we are, for example, going to use 10 million rows of sample for each model we want to prepare, for each edge unit we want to prepare model for. So instead of using 10 million rows for 20 edge units, we are going to use 10 million rows for each edge unit, and it's going to help us a lot to prevent the imbalance feature that we have in the data. It's simply the edge unit, because every edge unit performs and acts much different from each other. So to do this, we can prepare the data set for all the edge units with top of 10 million rows for each, and then run the Pandas UDF upon this data frame, and pass you on the group by the selected features that we want to run model that we want to run on each model for each value. So here we're going to put edge unit in our use case, and in the apply we can pass here the CTR function, the function that's going to prepare for us the CTR model to run XGBoost model, to run the validation, and of course run the post validation. So the post validation, it's a little bit different because we are running it as the first step in our pipeline. It's for example, if we ran yesterday a model and we want to run another one, a new one today, we first of all run the post-validation for all the models in the same distributed way. We just want to run for each ad unit. We want to run the post-validation for its model and send the same matrices and results on those models. So it's in our, we are turning all the model lifecycle, the data preparation, the training, the validation, and post-validation in the same way by using Pandas UDF. And the main difference here is that the Pandas UDF function that we want to pass to apply is going to run across all the cluster between all the instances in the cluster. So by running all those models in a distributed way, all the life cycle of all the models in a distributed way, by leveraging the same technology that we already used, Spark and XGBoost, for example, it can also support TensorFlow with the TensorFlow connector. We can run all those models in 1 hour in parallel across the cluster. The main achievement here is that we don't need to handle all the maintenance. The Spark already doing all the optimization and resource management. And for example, we saw in the cluster, we saw that in specific machine, we have 4 models that runs across the workers of this instance in parallel, because every model had like 2 million rows. But in the same, when we look at different instances in the cluster, we saw that we have one instance that runs 1 model with 10 million rows, because we passed in the Spark Submit, we passed more dynamic parameters, and in this way we use the cluster in most efficient way, instead of, for example, manage a pipeline for every model and always to think to choose the right instance for this model. Spark already in the same way that it handles data, it can handle in this use case also the model in the same distributed way. In this way we can support not only 20 models, we can support like 500 models, and we already started to work on it. For example, run a model for each campaign and for each brand and ad unit. So we're glad to have any feedback from you guys. Thanks a lot.